Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams PFM, IFM, and LTM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam P on probability. An individual experiences a loss due to property damage and a loss due to bodily injury. Losses are independent and uniformly distributed on the interval from 0 to 3. Calculate the expected loss due to bodily injury given that at least one of the losses is less than 1. And here's the solution. So let x be the random property damage loss and y be the random bodily injury loss. Because the original distribution is uniform, the conditional distribution, conditional on at least one of the losses being less than 1, is also uniform. But on the union of two non-overlapping regions, first one where x is between 0 and 1 and y is between 0 and 3, this is the region where x is less than 1 and y can assume any value, and x between 1 and 3 and y less than 1. This is the region where y is less than 1, but x is more than 1, implying that the two regions do not overlap. The area of the union of those two regions is 3 plus 2. The first region has the area of 1 minus 0, so 1 times 3 minus 0, so 3. So 1 times 3 is 3. And the second region has the area of 3 minus 1 times 1 minus 0, so 3 times 1, which is, 3 minus 1 is 2. So 2 times 1, which is 2. And the total area is 3 plus 2, so it's 5. And hence the uniform conditional density is 1/5. Therefore, the expected loss due to bodily injury, which is y, given that at least one of the losses is less than 1, is the expected value of y, given that x is less than 1 or y is less than 1. And then we just take two separate integrals of y times the density over the two non-overlapping regions. So first, for x between 0 and 1 and y between 0 and 3, y times the density of 1/5 dy, and then dx, the second integral with respect to x. And then the second integral is for x between 1 and 3 and y between 0 and 1 of y times the density of 1/5 dy dx. And that becomes the integral from 0 to 1 of 1/10, because the integral of 1/5 y is 1/10 y squared. This is evaluated from 0 to 3 for the first integral and from 0 to 1 for the second integral. So evaluated from 0 to 3 gives us 9/10. And evaluated from 0 to 1 gives us 1/10. So we end up with integral from 0 to 1 of 9/10 x plus the integral from 1 to 3 of 1/10 dx. That's a constant that we're integrating, so it's just that constant times the length of the interval on which we're calculating the integral, and that's 9/10 times 1, so 9/10, plus 1/10 times 3 minus 1 is 2, so 1/10 times 2, that's 2/10. 9/10 plus 2/10 is 11/10, so 1.1, which is answer C. Please remember this is copyrighted material. The problem itself comes from a Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.